The topic of this video is polynomial addition and subtraction. So essentially what we're going to do is we're going to take some polynomials of different varieties and add or subtract them, following just some basic rules of addition. So really our goal is this. We're going to distribute where we need to, and we're going to combine any like terms, and then write the polynomial in standard form. These examples are all single variable problems where we just have one variable for each term. So I'm going to grab a couple here and do those. So let's do like number 7. So the first thing I'm noticing here is that I do have some parentheses, and potentially I'm going to have to distribute. It's a good idea for us to distribute first before we start looking to combine any like terms. And I messed that up. Let's try that again. All right, let me grab a pen here. Sorry about that. And so the first thing I'm going to do is distribute that 5 to the 4x squared to the negative 3x and the 2. So that gives us 20x squared minus 15x plus 10. There's nothing I can do as far as distributing in the second set of parentheses, so I'm just essentially going to bring these guys down and go from there. So again, I'm looking to combine any like terms and put this in standard form, meaning the highest degree exponent first. So that's what I'm going to do first, is identify what is my highest degree exponent. 3 is my highest exponent, so that's the degree of the polynomial. And so that is my first term, 3x to the third. There's no other x to the thirds that go with that, so I've taken care of that term. But I do see some like terms here when I've got 20x squared and negative 2x squared. So 20 and negative 2 would give me 18x squared. So those are taken care of. Then I've got negative 15x. And then the 10 and the 5 are going to go together to give me 15. So again, I've combined all like terms. They're in descending order as far as the exponents go. So I'm good. That would be my answer for that particular problem. Same thing down in the second one, number 8. The first set of terms, I'm just going to bring them down. But for the second one, I'm going to have to distribute that negative 6 to all these terms here. So negative 6 times 7 is negative 42x to the fourth. Negative 6 times negative 6 is 36x to the third. Negative 6 times 4, negative 24x. And plus 48 there for our last term. So again, I'm looking to put in standard form, so I want to combine any like terms where appropriate. Let's go green this time. X to the fifth appears, or the 5 appears to be our highest exponent, so we're going to leave that one first. So that's taken care of. I do have a term that's x to the fourth, negative 42x to the fourth. That one's done. X to the thirds, I have a negative 7 and a 36. That's 29x to the third. Those are done. And then I have my x squared term here. That one. An x, a negative 24x. And then the negative 6 and 48 together will give me 42. So again, really, we're distributing, we're putting like terms together. Same variable, same exponent, we can put them together. If one of those things is unlike, then it doesn't work. That's great if we have single variables, but we're also going to look at multivariables, things that have multiple variables in each term. So on the left-hand side and the right-hand side, we have different examples of multivariables. So on the left-hand side, we have ones that can be combined, and the right ones we have that can't be, that we are not able to combine. The ones that we can combine, we can do so because the variables and the exponents are the same for each of the pieces of the term. So looking at the first one, we have x's and y's. Both of them are x squared and y. Versus over here, we have an x squared and a y, but an x and a y to the third. Those are not like terms, so we can't put them together. Same thing down here, x's and z's, same exponent, or same variables with the same exponents on both pieces. Not over here. A's and b's are the same here, not the same over here. So we can't put those together. Now, when we eventually combine these terms, we have to be very careful that there's really no such thing as standard form with multivariable polynomials. What we're going to be doing is taking our first variable, whatever it happens to be, and base it off of that term and put it in descending order. However, doesn't really mean, if you switch the terms around, that it's wrong. We're not really going to be focusing too much on standard form here because there's really not such a thing. It's more about, can you combine terms that are supposed to be combined correctly. So as an example, we want to talk about degree also. And degree is very similar to what we talked about with single variable polynomials, that we're looking for that highest exponent. But what's different is now we have two variables or more. So we have to consider each different variable and then consider them as an entire term. Looking at this term, we have 7x squared y. There actually is an exponent there of 1. So my degree in that case is 3 because I'm going to take the exponent on x and the exponent on y and add them together for that term to get a degree of 3 for that term. And same thing for this next one. We have a degree of, an exponent of 3 for x and an exponent of 2 for z. Putting them together gives us a 5. That's the degree of the term. And so on. Again, just some more examples. When we look at the degree of the polynomial itself, then we have to consider term by term what's happening, and then look for our highest number. So as an example with 6x squared y, the degree on that one would be 3. When we have xy to the third, there's a 1 there. The degree on that is 4. That term has the highest degree. That's the degree of the entire polynomial. And this one we have a degree of 3 and 2, so 5. Here we have a 2 and a 5. That's 7. Our degree would be 7. All right, so again, those are just some examples of getting degree. Now we want to put the kind of the meat and potatoes of this whole thing together and get to where we actually want to put some terms together and identify the degree of your answer. So the first thing we want to talk about is what the heck is a like term. That's going to probably be better illustrated with number 12. We have A's and B's in looks like every single term, but these are not all like terms. The ones that are like terms are these because they have a squared and b to the first. And these because they're just ab. If we look at that last term that it doesn't have a match, it doesn't have a match because the 2 for the exponent is not attached to the a, it's attached to the b. But we don't have anything to match up with it. So as we talked about before, we're going to take our degree, or I'm sorry, our descending order, we're going to put it based on the first variable that's mentioned. In this case, it's a. So I'm looking for an exponent of 2 on the a, and I have that with these two terms, negative 4ab squared and 11ab squared. So when I put those together, I get 7. Or sorry, I don't know why I said ab squared. A squared b. We get 7a squared b. The next thing I'm looking for, I don't have any more exponent of 2. So I'm going to kind of lean towards this one being the next term because it's a to the first, but it's also b squared. Okay, then we can add these together to give us 21ab because they're like terms. So we add the coefficients. So it doesn't get much more difficult than this except when we have to distribute. Oops, I went too far. So when we distribute, we're really doing the same thing. When we look at number 13, we're going to take that 5 and distribute it. I gotta grab a pen, I'm sorry. Grab a 5 and go here to here and here. So we're going to have 5y to the third, z squared, minus 10y squared z to the third, plus 5. And then we distribute the 2. So we're looking for like terms, and again, like terms have the same variables and exponents on all pieces. So my highest exponent the variable that's mentioned first is y. So I'm looking for an exponent that's the highest for that. It looks like it's this one right here, y to the third. And we do have a match with this over here. They both have y to the third and z squared. Putting them together, I get I don't know what happened. Sorry. My PowerPoint left. Sorry about that. We had some technical difficulties. So we can put that 5y to the third and the z squared together to give us 7 of those. So the next thing I want to do is to finish this off. I've got a y squared and a z to the third. That would be my next term that I'm looking for. So minus 10 y squared z to the third. So those are gone. I don't have anything with the yz to match up, so I just kind of write it there along for the ride. and the 5 and the negative 6 would give me negative 1. So again, that's how we're going to add or subtract polynomials. We want to distribute, combine our like terms, and where possible put in descending order, but if it's multiple variables, we don't want to do that. And I did forget one little part here, degree. So the degree of the answer, so I'm looking for my highest exponent. Here I've got a 5 together, and a 2. So my degree would be 5. So again, multiple variables, we're going to add our exponents together to get our degree.